Just a minute, I move this one. Okay, so if there is no question, we can move. So we have R1 over R2 is equal to the square root of the density of gas 2 divided by the square root of the density of gas 1. So gas 2, gas 1. So you can see the rate of diffusion of a gas is inversely proportional to the square root of its density. The rate of diffusion of a gas is inversely proportional to the square root of its density. So you can see that R1 is a numerator, the density of gas 1 is a denominator here. So the square root of the density of gas 1. Then R2 on the other hand, R2 is a denominator, the density is a numerator. So that's what we mean by they are inversely proportional. They are inversely proportional. So if there is no question, I'm now going to pick this one here. I'm going to pick this one here, and derive other equations around it. This one. I'll pick that and then use it to derive other equations around it. Then we'll be able to apply the same now in working out some questions. So allow me to rub my board here so that I create space. Yes, okay, so R1, I'll write here. Okay, so we have R1 over R2 is equal to R1 divided by R2 sorry, those are rates, they are rates, so divide by R2, this should be R2, can be written as it is equal to the square root of the density of gas 2 divided by the density of gas 1. So that's the first equation. So this one is our equation number 1. That is equation number 1. So equation 1. Now equation 2, we can derive other equations around this equation because we know that density from Form 1 physics, density is equal to mass divided by volume. That therefore means density is directly proportional to mass. So where there is density, we can also put mass there. We can put mass there because they are directly proportional. So that will therefore lead to another equation where the rate of diffusion of a gas 1 divided by the rate of diffusion of a gas 2 will now be equal to nifukuzie hiyo kuko will now be equal to the square root of the mass of gas 2 divided by the mass of gas 1, like this. So this is our equation number 2. This is our equation 2. So whenever there is rate, as you can see here, whenever there is rate, then the other quantity will be inversely proportional. R1, density 1 here. R2, density 2 there. Then mass, R1, M1 there, R2, M2 there. So rate is how much volume is diffusing per unit time. So you can be given the volume that has diffused per unit time, and the units will be cubic centimeters per second or per minute, and so on, or decimeters, sorry, pm cubed per second, and so on. So that's what you need to be able to know. Then, just a minute. Okay, so there we are. Then next, we can now use these equations to come up with other equations. We can derive so many equations from this one here. We can come up with several others. So like now, we can now relate the mass of diffusion with the time taken. So we know that the time it takes for a gas to diffuse will be directly proportional to the mass of the substance which is diffusing. So if that's the case, then we can also come up with other equations for that matter. So I'm going to remove this one. I hope you are already written, so that I create space here. Okay, so what about mass? The heavier the mass of the gas, the longer it takes to diffuse, and therefore mass and time are directly proportional. So I can also compare the time taken by gas 1 to diffuse in relation to the time taken by gas 2 to also diffuse. So these ones will be equal to the square root of the mass of gas 1, molecular mass. I'm talking about relative molecular mass, the mass of the molecule, divided by the mass of gas 2, the mass of gas 2. So that will be the third equation. The third equation here. Sorry, just a minute. Okay. So in that case, this now becomes our equation number. That is equation number 3. That is equation number 3. You can see where there is time, then they are directly proportional. The heavier the gas, the longer it takes to diffuse. So it's directly proportional. We can also relate time and density. So if that's the case, then it will also be T1, time taken by gas 1 to diffuse, divided by T2, time taken by gas 2 to diffuse, will also be equal to the square root of the density of gas 1, density, I can make it better, divided by the density of gas 2. So this is our fourth equation. This now becomes our fourth equation. Kwa hivyo, the question you are asked will help you choose which equation you are going to use. So that is our fourth equation. We had written the others. Where there is a rate, I can write it here so that you compare over R1, R2, sorry, is equal to the square root of the density of gas 2 over density of gas 1. This is this was equation number 1. The equation number 2 was R1 over R2 is equal to the square root, sorry, is equal to the square root of the mass of gas 2 over the mass of gas 1. So you should be very keen. If you have two gases, you should be very keen. The rate of gas 1 should be inversely proportional to the rate of gas 2, to the mass of gas 2. The rate of gas 1 should be inversely proportional to the mass. So hii ikiwa numerator, hii ni denominator. So mahali kuna rate unaweza ona kwamba the other quantity will be inversely proportional. Where there is rate, you can see that. Where there is rate, you can see that. That's Graham's law. But where there is time, you will see that they are directly proportional. There, there, and there. So having done that, I now want to look at examples to emphasize my points here. So these are the 4 equations. So depending on the question, you can choose which one you are going to use, depending on the values you are given in the question. So I want to begin by looking at what we had in our notes. So this one here, the first question. A given volume of nitrogen gas, N2, remember nitrogen has atomic number of 14. So N2 will mean it is 14 multiplied by 2. That will be 28. Requires 68.3 seconds to diffuse through a tiny hole in a chamber. Under the same condition, another unknown gas requires 85.6 seconds for the same volume to diffuse. What is the molecular mass of this gas? What is the molecular mass of this gas? And the examiner forgot to add some other information. N will be equal to 14. One nitrogen has atomic mass of 14, and this is a molecule, the atomic molecule, a gas made up of 2 molecules. So the molecular mass, that's the meaning of this term here, molecular mass, the mass of the molecule. So molecular mass of nitrogen gas will be 14 plus 14 because it is N2. 14 plus 14, that will be 28. So I have time for nitrogen to diffuse and I have its molecular mass. This is 28. Kwa hivyo nitaangalia kwa zile equations tuko nazo, nitaangalia ni gani inaniruhusu nitumie time na mass. So you'll find that it is equation number 1, this one here. It is this equation here, this one. Because I have time and I have mass. So I'm going to apply these equations to answer that question. So if I can just remove this one, if I can remove this one here, so that I create space here. So I'm using that equation to answer the other bit. So this one here, this is the equation we are using, this one here. So I want to see if we can now apply what we have learned to solve that problem. So if this is the one we are using, I allow me to write here. So T1 over T2 is equal to the square root of M1 over M2. And looking at the question, T1 for nitrogen gas is 68.3 divided by T2 is 85.6. So now I'm going to write, because they are directly proportional, I'm going to write T1 here. T1, I'm applying this formula here. So T1, that is 68.3. I don't know why somebody should log in late. Okay. T1, 68. 68.3 and 85.6. So 68, 68.3 like this, divided by 85.6, or is it the other way, is equal to, I don't know, this fellow here. Andrew Moore, please mute your mic, always. Mute your mic so that we communicate. Dennis, very simple instructions. Mute your mic if you are not the one talking. Okay, then this will be equal to the square root of the mass of nitrogen gas, because time and mass are directly proportional. So 28, I've explained why it is 28. It is 14 plus 14. Nitrogen is written as N2. So you add the two masses. So 28 divided by the mass of the other gas, it is unknown. So tutaita gas X. We will call it gas X there. Okay, so at that point, what now remains is simple mathematics. So there are several options when you reach here. You have the option of squaring both sides, so that you now remove the other bits, or you can decide to, you have the option of squaring both sides. I've said that here, or you can decide to work out 68.3 divided by 85.6 before you do the others. So there are those two options for us here. So I will test both of them so that I see if you can follow. So 68.3 divided by 85.6 is equal to square root of 28 over mx. So I'm going to pick the first one where I'm squaring both sides. So I'm squaring here. So you put a bracket, then you square that side. You also do the same here, then you square. So we square this side and square this side to remove the square root sign. So 68.3 divided by 85.6. What is the answer? 68.3 divided by 85.6. What do you get? Yes, John. 0.77979. So we are dividing by 1. Is it out of 1 now? Is it okay? Out of 1, is it okay? Then it is equal to 28 over mx. John, I want you to confirm this side, have we squared? We are not yet. We have not yet squared. So it is the result of 68.3 divided by 85.6. Yeah. Then when you square it, 0.6366. 0.6366. See. So 0.63 66 we are dividing by 1, which will now be equal to 28. 28 divided by mx. So we are looking for mx. Mx will now be equal to, you cross multiply. So 0.6366 mx is equal to 28. So mx will be equal to Ambrose. Mx will be equal to, we cross multiply here. So 0.6366 mx is equal to 28. What is mx? Ambrose? Andrew Moore? Yes, Samuel Gumao. 43.98. That is 43.98. So 43.98.98. So that is what, according to the question, that the units will be what? It is the molecular mass. So that is grams. The molecular mass, the mass of the molecule. So that will be grams. That's your unit. So 43.98 grams. There's no harm when we write G there, grams. So that will be the working for that question. So you apply the formula, then use the formula to come up with the other details. So that's the formula. This one here, that's our formula. So we apply that formula to work out the questions, as you have seen there. It is as simple as that. Step 1, substitute in the formula. Then step 2, simple mathematics, you get the value of mx. Yeah, so the other option at this point was to get the square root of 28, and then I remain with the square root of mx. So I can also have another option where I divide 68.3 divided by 85.6, and I get 0.7979 will be equal to the square root of 28. So this is divided by 1. This is out of 1. Be equal to square root of 28. We can work out that. The square root of 28 is what? Square root of 28. The square root of 28. You don't have calculators. So that is 5.29. 5.29. So I would write here 5.29. Here 5.29, then divide by the square root of mx, like this, mx. So if I have that, then I can cross multiply again. I cross multiply and then do some mathematics. You'll end up squaring somewhere. You'll end up squaring to remove the square root sign, so that now you have mx. So it will be mx will be equal to, if I want to get mx, then itabidi nichukue 0.7 5.29 divided by 0.7979. Then I square both sides. I square the answer. I square whatever I get to give me the value of mx. Peter Tosh, you have a question? Peter, do you have a question? Yes? Okay, so that is example 1, where you are given the time and you are given the molecular masses. Question 2, a gas diffuses through a small aperture at the rate of 2 cubic centimeter per second. Oxygen diffuses through the same aperture at the rate of 3 cubic centimeter per second. Calculate the molar mass of gas G. So we are going to apply the formula that uses the rate. As you can see, this is the rate of diffusion, 2 cubic centimeters per second. That is the rate of diffusion, and you are even told it is the rate. So kwa hivyo utatumia formula ambayo ina relate rate of diffusion with the mass of the gas which are diffusing. Kwa hivyo nitafuta ubao, tafuta ubao kwanza ndio tufanye. Kama uko na swali utauliza. Ukiwa na swali uliza tafadhali, usikose kuuliza kabla hujaelewa. So there is our board. So nimepewa rate na mass, kwa hivyo tatumia hii formula inasema the rate of diffusion of oxygen gas, nimeambiwa ni oxygen, na hiyo ingine tumeambiwa ni chatone, ingine ni, so kuna gas G na kuna oxygen gas O2. Remember, it is written as O2. Don't forget that it is O2. So RO2 over the rate of gas G, Rg, like this, should be equal to the square root of the mass, because they are inversely proportional. The mass of gas G over the molecular mass of oxygen gas, O2, like this. So you can see the rate and the mass are inversely proportional. According to the law, where there is rate, then the other quantity will be inversely proportional. So rate and mass are inversely proportional. The next thing is now to substitute the values in that equation. Gas G, the rate is 2, and our friend oxygen gas, the rate is 3. So according to my equation, RO2 is 3 and RG is 2. I can also begin with the other one, and then that will mean I also reverse this one here. So I put here, so I'm going to put 3 to be my numerator, because it is the rate for oxygen gas. So 3 divided by 2 is equal to the square root of the mass of G, molecular mass, which I do not know, G divided by the mass of oxygen gas, molecular mass of oxygen, which is written as O2. Oxygen inaandikwa O2, O2. And each oxygen we have been told it has a mass of 16. If you look at the question, O is equal to 16. That means atomic mass of oxygen is 16. And oxygen gas exists as a molecule, which is written as O2. So if that's the case, then the total mass will be equal to 16 multiplied by 2, or plus 16. So times 2, which is equal to 32. So I have now 32 here, 32. That's the mass I'm going to use here, 32, like that, 32. Don't know if I have written it well. 32, that. So from there again, it is a matter of simple mathematics. You can remove the square root from the beginning by squaring this side. You square here, square. You remove the square root by squaring both sides. You square both sides, not one side. You square both sides. So that will mean I have 3 divided by 2, which is 1.5. Then square 1.5 square should be equal to what? 1.5 times 1.5. We are squaring 22.5. Confirm, please. 22.5. 1.5 square. Is it 22.5? Please confirm. Confirm what you are getting. 3 divided by 2, then we square. What are you getting? Dennis, Derek Mudusi, what do you get when you divide 3 divided by 2, then you square? What do you get? 2.25. 2.25, is that correct? Yes. Yeah. So 2.25 over 1 is now equal to mg over 32. So can we get mg? Can we get the mass of gas G? So we are going to cross multiply here and then we divide. Cross multiply. There is no even division here. Philip, go on. You are getting 72. Very good. Andrew Moore, confirm. Andrew Moore, confirm. Andrew Moore. Don't know if you are online. Andrew Moore. Okay, so 72. Do you agree? Yes, Cyrus. Cyrus? 72 is correct. Okay, thank you. So that is another example involving the rate and the mass. I've also looked at one involving time and the mass. In the other question, you can be given different volumes. For example, I want to look at question number, where is it? Question number 5. Here, this one here. I'm looking at that question number 5. I'm hoping time will allow me. So I'm looking at question number 5, this one. Maybe you can write it down so that when we do it, you are able to follow. So question number 5. Let me share my screen. This question here. So you can write it and then we do it together. So 1 minute, you can write it, then we do it together. Okay, so I hope you are good. Philip, you have a question? Or do you want to work out? Yes, go on, please. Oh, no question. Okay, so look at this question here. We are given two gases with different volumes. So one is 140 cubic centimeter of nitrogen gas, N2, diffused through a membrane in 70 seconds. How long will it take 200 of carbon dioxide gas to diffuse through the same membrane under the same conditions of temperature and pressure? So the question is incomplete. N is equal to 14. Hizi mtapewa kwa mtihani. Carbon is equal to 12 and oxygen is equal to 16. So hizi unapewa kwa mtihani. Ni wewe ujue carbon dioxide inaandikwa CO2. Nitrogen gas inaandikwa N2. So when you are using those masses, you remember to get the molecular mass by adding the masses. So 140 cannot be compared with 200. That means for us to be able to compare the rate of diffusion of nitrogen gas with that of carbon dioxide, lazima tuwe na equal volumes of gases. So I'm given the volume of carbon dioxide, which is 200, and the volume of nitrogen gas, which is 140. We must keep the volume constant. Kwa hivyo kama nimepewa 140 taking 70 seconds, then I need to get 200 cubic centimeter of nitrogen gas. Will take how long? So that the 200 cubic centimeters is the same volume with the 200 cubic centimeters of carbon dioxide. So huwezi tumia hii 70 kwa sababu hizi volumes ziko tofauti. Hii 70 unaweza itumia kupata the time taken by equal volume of nitrogen gas. So if 140 takes 70, what about 200 cubic centimeter of nitrogen gas? So that way you will have equated the volumes of the two gases. So if you are given different volumes, you begin by getting the time for equal volumes of gases for you to be able to use the formulas. Okay, so hapa tutaanza na kutafuta the volume, the time taken by 200 cubic centimeters of nitrogen gas. And how do we do that? Tutasema if 140 tutasema if 140 is taking 140 cubic centimeter, is taking 140 cubic centimeters, is taking 70 seconds, 70 s. How long will 200 of the same gas take to diffuse? 200 cubic centimeters will be equal to what? So 200 will be equal to cross multiply. What are you getting? So if 140 of nitrogen gas takes 70, what about 200? We are using that to equate the volumes of the gases before we use the formula. So John, you are getting what? 100 seconds. 100? Yeah. Yeah, so now the new time taken by nitrogen gas will be 100. So N2 will now be equal to, now take 100 seconds. So now this is the time we are using in this working and not 70. Kwa sababu 70 ni time taken for 140 cubic centimeters, but the volume of carbon dioxide is 200. So we cannot use 70 seconds. We are going to use 100 seconds because it is the time taken by equal volume of gases to diffuse. So now I'm going to use the formula of time and mass. Time and mass. So T1 over T2 is equal to the square root of mass 1 over mass 2. So that's the formula. T1, where 1 here is now N2, nitrogen gas, this way, divide by T2. T2 in this case is CO2, carbon dioxide gas. Time taken by carbon dioxide, equal volumes, they must be equal volumes, is equal to the mass of nitrogen gas. It is 14 plus 14, which is 28, divided by the mass of carbon dioxide, CO2. Carbon is 12 plus 16 plus 16, CO2. 12 plus 16 plus 16, we are getting 44. 44 like this, 44. Yeah. So we have, okay, I have already substituted. So this T2, this TN2, we have it. We already have it. This one here. The time taken by nitrogen gas. Tayari tuko nayo. Kwa hivyo nitatoa hiyo na niweke the actual time. So it is now 100 divided by the time taken by carbon dioxide, CO2, this way. So what remains is now mathematics. So you have several options. You can get the square root of this, the square root of 28 divided by 44. Square root of 28 divided by 44. Divided by 44, the square root. Joseph Wambua. 28 divided by 44, then get the square root. Okay, Andrew Moore. So 28 divided by 44, then the square root. Andrew, you can go ahead. Andrew, go on. 0.79. You have squared already. Oh, 0.7977. So 7977 like this. Sorry, I'm writing using a mouse here. It is a bit. So 0.7977. Sorry, let me admit these ones. So 7977. Okay, so divide by 1. Then I can remove this one here. Can remove this one here. Yeah, so we have this one being equal to that. So if that's the case, then that's what we have. Then you are going to take 100 divided by TCO2 is equal to 0.7977 divided by 1. So cross multiply. What do you get when you cross multiply? Cross multiplication will give us what? TCO2 will now be equal to, so cross multiply. What are you getting? It will be 100 divided by 0.7979. You are getting what? $100 divided by 0.7977. You are getting 125.36. Confirm. 125.36. 125.36 seconds. Confirm if that's what you are getting. So you cross multiply and then you have the answer. Is that correct? Is this correct? Cyrus, confirm if this is correct. Okay, Christian, any question? Christian? Christian, do you have any question? Is there an area you have not understood? You are fine? Okay, so I'm writing this formula down so that you can follow what we are doing, all of you. So that is the formula we are applying. The time is directly proportional to the square root of mass. The longer the time, the heavier the gas. So they are directly proportional. But nimesema mahali kuna rate zitakuwa inversely proportional. Mahali kuna time zitakuwa directly proportional. So hapa T1 over T2 is equal to square root of M1 over M2. So T1 tumesema hatuwezi tumia 70 kwa sababu 70 ni time taken by time taken by 140 cubic centimeters to diffuse. But 140 is a different volume from that of carbon dioxide. Ni tofauti na ile ya carbon dioxide, as you can see in the question. 140 ni volume ya nitrogen gas na 200 ni volume ya carbon dioxide. These two are different, so hatuwezi tumia hiyo time ya 70. Lazima tuhakikishe it is equal volume of gases diffusing. So how do we ensure it is equal? We use what we are given to get what we want. 140 is equivalent to 70 seconds. What about 200? So that way we have equated the volumes of the diffusing gases. So that is why we are ending up with 100, and we are now using 100 to now work out the time taken by the other gas. Time taken by the other gas. That's the method 1. Method 2, you can use that whatever you are given to get the rate of one gas, because rate, tumesema rate is equal to, rate ni sawa na speed, so rate is equal to volume diffusing per unit time, so R over T. Na ukiangalia hiyo swali vizuri, ile tumepewa volume ni nitrogen gas. Tumeambiwa 140 of nitrogen diffuses through a membrane in 70 seconds. So tunaweza tumia hiyo tupate rate ya nitrogen gas. So how do we do that? So tutasema R is equal to volume over time. So the rate of nitrogen gas R N2, the rate of nitrogen gas will be equal to its volume divided by the time it takes. So hii itatupea rate of diffusion of nitrogen. So is equal to 140. We use the volume we are given, 140 divided by 70. Divided by 70. So this will be equal to, is it 2 cubic centimeters per second. That's the rate of diffusion of nitrogen gas. So nikiwa na hii naweza tumia ile formula ingine, ile formula ya rate na mass. So naweza tumia hii ya R1, where R1 is now the rate of diffusion of nitrogen gas, over R2, the rate of diffusion of the other gas, which is CO2. Is it CO2? Let me confirm. CO2, yes. Yes. So N2 over R CO2 will now be equal to, it will be inversely proportional to the square root of the masses. So it will be inversely proportional to the mass of CO2 over the mass of N2. So they are now inversely proportional. Don't forget that. That's the formula we are applying here now. So niko na rate ya nitrogen gas nimecalculate. So nitaandika hapa 2 over, allow me to use x because of time, is equal to, where x is the rate of diffusion of carbon dioxide, is equal to the square root of the mass of CO2 tumecalculate ni 44. So unachukua mass ya carbon umepewa kwa swali. Let me show you. Nachukua mass ya carbon ni 12 plus mass ya oxygen 2 ni 32. 16 plus 16 itakuwa 32 CO2. So CO2, carbon is 12 plus oxygen plus oxygen. So 12 plus 16 plus 16 is 44. Nitrogen the mass of one nitrogen is 14, zikiwa mbili itakuwa 28. So hapo unaandika 28. Andika 28. So at that point you can get the square root of 44 divided by 28. What's the answer? So 2 over x is equal to, what's the answer? 44 divided by 28, then get the square root. Samson? I was not sharing. So can you see it now? Okay. Can you see my screen? Okay, so I'll repeat that. So I said that for this question here, for this, we can also use the second method where you begin by getting the rate of diffusion of the gas whose volume and time you are given. Kwa hivyo we are not converting this to 200. We are using it the way it is. So 140 and 70 will give us the rate of diffusion. So rate is given by this formula here, the one I've written there. Rate is equal to volume divided by time. That's the formula. R is equal to volume divided by time. Kwa hivyo nimepewa volume ya nitrogen gas ni 140 na time ni 70. So 140 divided by 70, I get 2 cubic centimeters per second. That's the rate of diffusion of nitrogen gas. Then if I have that, then I can now apply this formula which talks of rate and mass. So Rn2 over Rco2 is inversely proportional to the square root of their masses. So that's why I've written mCO2 at the top and N2 at the bottom. So where there is rate, they will be inversely proportional. So that we now substitute the values. The rate for N2 is 2, divided by the rate of CO2 is x, is equal to the square root of mass of CO2 is 44 divided by mass of N2 is 28. Kwa sababu nitrogen ni mbili, kila moja iko na mass ya 14. So what is 44 divided by 28, then the square root? Unapata ngapi? 44 divided by 28, square root. Square root of 44 divided by 28. Square root of 44 divided by 28. Candidates. Yes, Samuel Ngumbao. 1.2254 over 1. So what is x? X will be equal to, we cross multiply. So x will be 2 divided by 1.254. Andrew Musao, what is x? Yes, Cyrus. 1.5. Sure. 2 divided by 1.254. 2 divided by 1.254. You are right. 1.5. Cyrus? 94. 95. 95. Very good. So what is this? This is what? Cyrus, what this is this value is for what now? This is the what? The rate of diffusion of, very well, the rate of diffusion of carbon dioxide. So you write cubic centimeters per second. But the question says calculate the what? Calculate the how long will it take carbon dioxide. So we need the time taken by carbon dioxide. Kwa hivyo sasa utatumia hiyo utafute hiyo time. Utatumia hiyo kupata time. Na tumejua kwamba rate is equal to volume divided by time. So tunaweza tumia hiyo. Tuko na volume, tuko na rate, now we need time. So I'll write it here so that you follow. So rate is equal to volume divided by time, t. So I can put 1 here. So R we have it 1.5595. Then is equal to volume ya carbon dioxide tumepewa ni 200 divided by time. We are looking for t divided by t. So over 1. So what is t? T will be equal to what? What is t? What is t? Yes, John. So t is equal to 125.4. Philip, do you agree? Okay. So that's the time taken by carbon dioxide. If you check that and what we had got here, they are almost similar. Only that now this is 125.36, can round off to 125.4. This is 125.4. So they are the same. So there are two methods. If you choose to use the first one, if you are using this formula here, ukiamua utumie hii formula, then hakikisha ya kwamba the volumes of the diffusing gases are the same. You cannot use it unless the volumes are the same. You cannot compare the rate of diffusion of gases whose volumes are different. They must be the same. That's why we started by getting the time taken by 200 cubic centimeters. Ndio hiyo volume ikuwe same na ile ya carbon dioxide. So una apply hiyo. Ingine unaweza tafuta rate of diffusion na utumie ile formula inaongelea rate. Na ukumbuke they are inversely proportional. You will still get the same answer. Yeah. Okay, any question? Any question? I want to believe up to now you are now able to follow what I was doing that day. There were some issues. You can now work out the questions comfortably. Can you? Yes? Yeah. So now I'm going to post this in the WhatsApp group. There are 6 questions. There are 6 questions. I'm going to post there. We have done the 5th one. So I'm going to post the remaining so that now you try it. Alafu tuiangalie kesho tuanze mol. So tutaanza mol kesho. Mol. The easiest topic in chemistry we are starting tomorrow. The mol. Then we'll reach some. So let me wish you a good day. Let me hope I'll meet you again tomorrow. Victor Mudui, you have a question? Okay, have a great day. We meet tomorrow.